Okay, hi. My next little tutorial today is going to be on Lab 5. I decided not to write out a big long diatribe about Lab 5. I think what's in the lab book is very straightforward, but it is a little shaky because you have to come up with the experiment yourself. And I wanted to give you a rough idea about how it works. Just rough, okay? So supposing you have in your mixture an acid, I'm going to be very general, of some kind. You have a base of some kind. In the last tutorial, we talked about these compounds and how they react with base and acid. Supposing you have some kind of neutral, I'm going to use the same neutral compound that I used in the last tutorial. And supposing you have a salt of some kind, like sodium bromide. All right, what it says in Lab 5, I'm not giving anything away. It says all organic compounds are soluble in dichloromethane, acid, base, and neutral. And it says that the salts will not be soluble in dichloromethane. And you should know this because when you put your drying salts in last week to dry your compound, you noticed that it laid on the bottom of the dichloromethane solution. So this suggests, right, that you could take these molecules and dissolve them in dichloromethane. This suggests that this will not go in. Now again, so you can picture this better, you're going to get a combination of 3 to 4 molecules mixed together, and they're all going to be solids. It's just going to look like a big solid mess. All right? If you added dichloromethane, the expectation would be that anything organic in there, and you might not have all of these, okay? But anything organic in these would dissolve in the dichloromethane, but if you had a salt, it wouldn't dissolve. So I want you to think about that. If all these go into solution and this does not go into solution, how would you get it out? How would you separate it? What method would you use? Okay? You could use some kind of method if this doesn't go in and these do go into solution. Okay? Now, a little more. So say you get that far, and now you've figured out how to separate those. And what I'm trying to do here is give you a little bit of a picture of it so it's not as foreign when you walk into the lab. But supposing you've created a solution of dichloromethane similar to last week with caffeine. And in the dichloromethane, you have your acid, you've got your base, and you have a neutral compound. This would be kind of an extreme case because most people will not have all 3. You're going to come up blank on some of these, okay? But you don't know, so you have to work it like they're all there. All right, now, you could, in principle, right, take acid and extract this molecule out because it's a base. You could take base and extract this molecule out because it's an acid. You did that last week. How did you remove gallic acid? Think about it. You want to apply the same concepts here. So for example, supposing I want to remove this molecule selectively, I would take a solution of 3 molar HCl. This is what's suggested in Lab 5, if you read Lab 5. And that would mean I would have hydronium ion in an aqueous layer. This is largely water. This is why it doesn't go into solution. And what you want to have happen is you want this molecule to migrate. The length of my arrows does not have much significance there. To migrate into this layer. So supposing this migrates into the layer, okay, what's going to happen? I want you to think about what will happen if this migrates into that layer, right? This is going to react with that. And if it reacts, this is not happening out in the air, by the way. This is happening in the flask. But if it reacts, it's similar to what I just did a few moments ago. You would have this plus water, right? How soluble is this in water compared to the amine. This is the conjugate acid of the amine. This is the amine. Okay, the amine, it has no charge. It's not very soluble in water. This is really soluble. What does that do to the equilibrium? Okay, so this gives you an idea about how you can remove a base, right? Similar idea for how to remove an acid, okay? So supposing you get to a point where you've got a flask, and in the flask you have water, and you have this salt. The pH of this solution is very low, okay? What do you have to do to this to get it back in its original form? What's wrong with it? It's not a base right now. It's an acid right now. How do you convert it from this form back to the base? What do you have to do? I bet you know what to do. You have to add something to that to convert it back to this form. When you convert it back to the free amine, it will be insoluble in water and you'll be able to isolate it. Similarly, supposing you have another flask, and this is kind of a strange shaped flask. Supposing in another flask you have this, because you've isolated it. This is water. This is really soluble in water. How do you get it back? What's wrong with it? What do you need to add to that to convert it back to the original form, which was the acid? The acid will be insoluble in water, and you'll be able to collect it. Now, at the end of the day, right, your funnel, right, has maybe not, some kind of neutral compound in it. This is not, I didn't even give anyone this neutral compound, so, you know, don't expect to get this, but there might be some neutral compound in there. It's sitting in dichloromethane. This is kind of like your caffeine last week. How did you get your caffeine away from the dichloromethane? What did you do? It's the same process. Okay? So you're supposed to come up with a plan or a flow chart that incorporates the things you learned last week about removing acids, removing bases, and isolating neutral compounds from a volatile organic solvent. Once again, these are all solids, okay? So I hope this helps a little bit. And again, I'll see you in lab next week.